Here's an example calculation question involving the Doppler effect. Let's say that there's a flatbed train car that has a piano sitting on it. The pianist, despite being a great piano player, is only hitting the A4 key, that is the key that makes a 440 hertz note. The train is traveling at 60 kilometers per hour, coming towards you, standing by the side of the tracks. What frequency are you going to hear? So here's a little sketch of the situation. And this is our equation for the Doppler effect, derived in another video. Before we go any further, we need to convert this 60 kilometers per hour into meters per second. And so we'll go ahead and do that. 16.7 meters per second. Now, looking at our Doppler effect equation, F naught here, that is our 440 hertz. The observer, you standing by the side of the tracks, are not moving, so that V observer is 0. And V source, that is our 16.7 meters per second. The speed of sound, we'll go ahead and use 343 meters per second. So the original frequency, 440 hertz, times the speed of sound, 343 meters per second, plus 0, so we're not even going to bother with that. On the bottom, 343 meters per second. And then the question is, are we going to choose the minus or the plus sign here? Because the train car is coming towards you, we're expecting a higher frequency. So we're going to use the minus sign. Because it's in the denominator, we choose the minus sign, which will give us a higher overall result. And so the train car moving towards the observer, towards you standing by the side of the tracks, is going to raise the frequency by a little more than 5%. 1.05 is our multiplying factor here. So about a 5% difference, giving us a frequency of about 463 hertz, and I've rounded to the nearest hertz. Now the second part of our question is, when the train car passes you, the frequency is going to drop. The train car all of a sudden, instead of coming towards you, is going away from you. And so we can use the same equation, the observer still not moving, but now we're going to choose our plus sign on the bottom. So we're going to have 440 hertz again, times 343 over 343 plus 16.7. 440 hertz. So our frequencies are going to be about 95% of the emitted frequency. And that brings us right to about 420 hertz. Now you may be thinking that this is kind of a hokey example, but this situation was used in 1845 by this guy, Bois Belot. I'm not sure I'm pronouncing the name right, but he was a Dutch chemist and meteorologist. And he got a train and a flatbed car and a bunch of trumpet players, not a piano, and in 1845 first demonstrated the Doppler effect. Christian Doppler, who first proposed the Doppler effect in 1842, only 3 years earlier, never did an experimental test of it. It was Belot 3 years later who did the experiment with a train traveling at about 60 kilometers per hour with a bunch of musicians on it.